In this video, I will talk about surface charges on a simple circuit. Now, what I'm using here, this is a simulation, a FET simulation on circuits, and I have placed, this is a wire. Again, the same wire goes around the circuit. This is just a bulb. I placed the bulb in the circuit to see the effect of the electrons moving and also to prevent the wire from overheating. And of course, this is a battery. This is the positive side of the battery. This is the negative side of the battery. And I want you to pay attention to, plus, minus, and the electrons, of course, are flowing away from the negative side of the battery, going through the wire, and then back to the positive side of the battery. Now, I also want to do the following. This is a simple circuit, and of course, you can construct it easily, and you can make measurements of the current. And that's what I want to do here with the simulation. I'm placing this non-contact ammeter here, and I get the current 0.9, somewhere else 0.9, somewhere else 0.9, 0.9, and 0.9. It seems that everywhere that you look is the current is the same. Now, that does make sense because I can see that the electrons are continually flowing everywhere, and they never accumulate, let's say in the corner or here or here. At the end of the day, current is charge per unit time. If you are here and you make a cross section of the wire here and you start counting how many electrons flow through, you will get the current. Because the electrons never accumulate anywhere on the circuit, if you count 3 electrons flowing per second here, you will also count 3 electrons flowing per second here. Now, if some of the electrons ended up accumulating, let's say here, then of course at this point you would be counting less than what you counted here. But there is no charge accumulation anywhere, so it makes sense that the current is the same no matter where you look. So I'm gonna start with this. And even if you do an experiment, you will find the same thing. Now I'm using the simulations here since that's the only thing that I can show you here in my video for now. But even experimentally, you will find that the current is the same throughout in this simple circuit. Here I have the circuit that I just showed you, and this is as I mentioned before, this is the positive side of the battery, this is the negative side of the battery. I want to use surface charges to see how I can create a current that is the same throughout the circuit. So I saw electrons. Okay, electrons were flowing this way, which means the force acting on the electron was going to the right, which means that the electric field created had to be to the left. Now here, because the electrons were flowing downwards, that meant that the electric field needs to be up. Here, electrons were flowing to the left, which means the electric field had to be to the right. And here, electric field has to be downwards. Here, electric field has to be to the left. Now, I will use what I told you before about surface charges. Since I want the electric field here to be to the left, I know that I can accomplish that using either negative charges or positive charges placed on the surface of the wire. Because I'm close to the negative side of the battery, I'm gonna use negative surface charges. And I'm gonna place, let's say, one here and one there. Since I have nothing on this side, indeed it does give me an electric field to the left. However, though, I also need to create an electric field that points up here. And if I continue to leave no negative surface charges here, if I place, let's say, a minus here and a minus there, I don't get an electric field that points up. I get an electric field that points down, and that's not what I want. So what I'm gonna do then is I'm gonna place 2 and 2. So this will be 1 and 1 here to get the electric field to the left. Now, the fact that here I have more surface charge than what I do here does give me the electric field to the left. The fact that I have some here but nothing here does give me an electric field that points up, but then I will end up having a problem on this part of the wire where I will not be able to get an electric field to the right. So I'm gonna add even more. So more negative charges, less an electric field to the left. Indeed, here electric field up. Yes, I have more negative charges here. Now I'm gonna look into the difference between this point and this corner here, as I did on the upper part of the circuit. I started from the midpoint more or less. Now from here I have nothing. Here I have some negative charge. Indeed, I do get an electric field to the right. I'm gonna do the same thing on next to the positive side of the battery. If I place a positive charge here, then the fact that I have no charges in the middle and some positive charges here will give me an electric field that points to the right. And because I have a little bit of positive charge here, if I place some more on this side, will give me an electric field that points down. And if I have some more on this side, I will also get the electric field pointing to the left. So this is, I want to make it clear here, I have no surface charges. This is the charge distribution, the surface charge distribution that gives you a gradient, a difference, so that you create an electric field everywhere inside that wire. Now, you may wonder, so those surface charges, can I see any effects that they have? Can I measure them somehow? How do I know that they really exist? There is yes, there is an experiment you can do to detect the presence of those surface charges. How fast do they accumulate where they need to accumulate in order to get the current and the electric field that you need inside the wire? It doesn't take much time. As soon as you make the connection between the wire and the battery, it will probably take time of the order of nanoseconds, like 10 to minus 9 seconds, for those excess surface charges to be distributed on the surface of the wire in a way that gives you the electric field and the current that you measure experimentally. So as soon as you make the connection, pretty fast, those surface charges will be found on the surface of the wire. Now, one last thing: when the area of the wire, the conductor, is constant, the electric field will also stay the same. I know from some theory that we've done, the current will depend on the electric field and the area. And what I mean with that, the current will be proportional of the product of the electric field and the area. Now, I will not go into the theory of proving that. It is fairly simple, but that's not the point of this video. The current is proportional to the strength of the electric field and the area. Now, as you saw in the simulation, I measured the current to be the same everywhere. If I is the same everywhere and the cross-sectional area of the wire is the same everywhere, this means that the electric field here needs to be the same everywhere. That's why you saw me drawing arrows for electric field that were consistent. They had the same magnitude everywhere inside the wire. Now, there are cases where the area of the wire is not constant, and in those cases you need to adjust the electric field so that the current is the same everywhere. But this is a relatively, one of the, I would say, the most probably simple circuit that you can use to study surface charges.